statement. First, I'm going to speak a little louder, if I can, because I have a quiet voice. I'm just getting over a cold, so that's why it makes it worse. My head's a little foggy, but I'll muddle my way through this. Tonight my topics is Dstar and Raspberry Pi, and also to talk about some microcontroller stuff. Now I know some of you were in the club meeting when I talked a bit about microcontrollers, so this will be a little bit of a repeat on that, but for the rest of you I guess it'll be new. I might end up running a bit short tonight because I broke everything. All my demos, I shouldn't have played with them last night, and I broke them all. So that's what I get. I shouldn't have waited the last minute to tinker with stuff. Had it all working on the weekend, and then, I'm going to make this change because I thought it'd be cool to show people, but womp womp, that didn't work out. I just didn't have enough time to get things restored back to working order, but I'll talk about them. So the other statement is I'm not a Dstar expert. This was my learning session into getting to Dstar as well. Bruce approached me to talk about Dstar and the dongle and integrating with the Raspberry Pi. So I thought it would be a good opportunity for me to learn it and share my experience with you guys. My previous experience is I do a lot of work with Raspberry Pi. As you can see, I have a few of them kicking around here. I do a lot of projects in my remote control airplanes with my internal. I do model railroading. I have them running my trains. I have them driving cars. I have them running my 3D printer. So I play a lot with these guys. So when he said, "Hey, why don't you try Dstar on the Raspberry Pi?" I'm like, "Hey, cool. That's a new toy." So we'll start off with, what is Dstar? Well, Dstar stands for Digital Smart Technologies for Amateur Radio. It's a digital voice and data protocol specification for, I feel like an announcer. The system was developed in the late 1990s by Japan Amateur Radio League, uses frequency division, multiple access, and minimum shift keying in its packet-based standard. There's going to be a test on this later. There are newer digital modes that have been adapted for use, but Dstar was the first to design specifically for amateur radio. Now, these devices, the reason why we need a dongle in this case is because this little chip here, the NWDR chip on this little dongle, it provides the codec for actually encrypting and decrypting the voice that you're sending across the network, so it shrinks it, it compresses it. And it's called the AMBE, the Advanced Multiband Excitation. Is the technology used in Dstar to compress the voice transmission. AMB is implemented on AMB 2000 and 2020 chips. This has an AMB 2000 chip on it. Now this, that's the one thing that's kind of, to me, seems a little different about Dstar is when you think about amateur radio, everything's, you'd think we open source, it would be something that, because we're all hobbyists. But this is one thing that is patented and licensed. So any device that has that can communicate on the Dstar network requires one of these devices, which has to be patented and licensed by the manufacturer. A little different. So we can't actually implement a software version of this yet. No one's backward has gone through and figured it out. So one day maybe, but. So what does Dstar do? Well, it does a lot of things. The Dstar DV mode, or digital voice mode, is basically essentially you have a hand radio. You can communicate with a digital packet that actually converts your analog to digital and will send it over the airwaves to a repeater, which could be in your area. So you don't need to connect to the internet to use digital voice, but if you do need a repeater, or you can do point-to-point. But the advantage of Dstar is you can connect your repeaters into the internet, and by doing so, on your I actually haven't used the radio, but on your radio you can connect to repeaters around the world, so you can transmit from your handheld to your local repeater, which can be routed to a repeater anywhere else in the world, and you can retransmit your communication, and you can communicate with people around the world using the internet, using the IP-based network. That's application one. You can also use it in DD mode, which will allow you to, if you have a network camera, you can check images and broadcast them across the network, and you can pick them up on a laptop that you can configure into your digital enabled radios. So you can actually use your radios to get on the internet. If you can, with an internet gateway, you can send email. It's not super high speed, but it'll work in a pinch. There's other modes where for GPS tracking, so you can transmit your GPS location from your radio, and whoever you're talking to can actually see that on their radio. It'll show up on the display. Again, I don't have much experience with that, but apparently it works. Or you can send short messages. The other one application is you can do call sign to call sign routing. So you can communicate with a specific individual. If you know their call sign, you can enter it in the program, and you can communicate directly to them back and forth. So one-to-one instead of broadcasting out to the world. So there's different types of dongles. There's the DV dongles, which is does the digital voice. It does the encryption, decryption of the packets, so the voice packages. But there's also the DVAP, which is a digital voice access point. What this does is it has the chip in it as well that does the compression and decompression. However, it also has in this case, has a 2-meter repeater. So now this can be used as a gateway into the Dstar network by communicating through your computer and onto the internet. So if you have a handheld radio and you don't have a local repeater somewhere within range, you can set up this as kind of in your house to communicate across the internet to connect to the world via IP. All of these dongles, which I have one right here, this one right here, they work on Windows, they work on your Mac computer, and they also work on Linux or Raspberry Pi, which is Linux. So what can be done with these dongles? Well, with this dongle, I don't require a radio. I can configure my computer to act as an access point using my speakers and a microphone, and I can directly communicate that way to anyone else that has either a handheld radio through a repeater or through a reflector on the internet. And so it can be used also to do call sign routing, so you can communicate with someone that actually has a radio, that has their call sign assigned to the radio. But again, you're just using your computer, don't need a radio. Oops, and I changed the page. Going too far. This device can also be set up as a remote AMD decoder. So what that means is I can install it on my Raspberry Pi, put it on my computer network at my house, and then my other computers can be set up to use that decryption and encryption chip remotely, which is kind of cool. That's what I was messing with last night when I broke things. So apparently I could get it working. So now that I've mentioned that, that's my very high-level version of Dstar. If you want to take a look at the dongle, I'll pass it around. It's a very simple device. What's a Raspberry Pi? Well, it's not something you eat. It does have chips. Oh, terrible. You can tell I'm on IT. So, what I have is multiple different versions. Raspberry Pi was developed, when was it developed? I would want to say about 4 years ago, I think, maybe. Anyway, the idea was for them to come up with a small computer that could be used in third world countries or around the world by hobbyists, cheap. And these computers, they came out and they're $35. And they have network ports, so you can plug them into your Ethernet network. They've got USB ports. This version A, it has an analog BNC connector, so you can connect to your video in. You can use that as your monitor. It has an HDMI as well if you want to plug it into your high-def TV to use as your monitor. And because it has USB, you can connect a VGA port, or you can plug in your keyboard or mouse, or a wireless adapter, Wi-Fi adapter. Now these guys, they don't have a hard drive, but they run on little SD chips. The first version used the full-size SD cards. Then newer versions, they use the micro SD cards to save space. The difference between these is they start with only 512 megs of RAM. It's running Linux. Linux is pretty efficient with memory, so it seems to run most applications. But they also started off, they've got these this little header right here, which is nice for interfacing. For guys like me that like building things, This has, what, 28 ports? If you can read that. So the first one, I can read it. Where does it say? There's 8 GPIO pins available. The rest are otherwise assigned. So a GPIO pin is a pin that I can control via software that I can program on the Raspberry Pi, where I can turn the pin on or off, or I can do some sort of digital communication, like serial communication, SPI, CAN bus, which is used in cars, I2C. These are all different serial communication formats that you can use to communicate with external devices from here. So for that, I can use it to control servos. I can use it to control drive fans. If I want to use the PWM, I can use it to limitless things, really, except limited to 8 pins, which is when these came out, they have 40 pins. So now I can have more servos and more adapters. Now the first one was only 700 megahertz. Yeah, 700 megahertz for Model A, which is this guy. 700 A and B, 700 megahertz. Then the next one, Model B version 2, came out. It was 900 megahertz, and it was quad core, not single core. So that was a huge performance increase. Then version 3, which just recently came out, is a 1.2 gigahertz, and it's 64-bit quad core. The enhancement that came with the third one is it has also a built-in Wi-Fi card and Bluetooth as well. And these ones have a gig of RAM as opposed to the 512 meg that the first ones have. So I'll pass some of these around if you want to take a look at them. They all look fairly similar. I'll send them in order. So this will be the A, then the B, then the 2,
I'm in charge of making
and
sure
then
these
the
don't
3.
get reversed.
So very subtle differences. The 2 and the 3, the advantage of them is they also have 4 USB ports, so you can plug more peripherals in. So you can have a keyboard and a mouse, and you can plug in a wireless card, or you can plug in a dongle. Plug in your Dstar dongle. So going from building on that, the Dstar dongle comes in 2 formats that will work with a Raspberry Pi. There's the USB one. The USB will work on Windows, Mac, or work Linux, almost any computer. It'll even work on, you can get applications for Android as well. So you can plug it into your phone if you have an adapter for USB. And then they also have the module that will plug right into the I/O pins on the Raspberry Pi as well. So you won't have to use one of your USB ports. Especially in the Model A, which is depicted here, you only have 2 ports, so you're usually using one for a mouse, one for a keyboard. So putting it directly on there will save you some space. It's not so bad with the newer ones because they have 4 ports, or you can use the hub if you want. So what I did was, as per Bruce's suggestion, I went with this thumb DV with the chip on it that has the drivers on their website to set up in the Raspberry Pi. I built this is going to be my Dstar station. This is a monitor that I bought from MCM Electronics. It's actually meant for a Raspberry Pi. Plugs into the Raspberry Pi's LCD monitor port, and it was only 40 bucks. It's not that bad for a high-def screen. And then I printed a case for it on my printer, so it'll stand up. So now, because I'm running a Raspberry Pi 3 on here, it's wireless, and I can plug it into my little battery, and I can be anywhere where there's a SHA open connection, and I can get onto the Dstar network. You can sit at, I look like a real pro sitting at Starbucks or something, talking to people. But hey, everyone does it with their cell phones anyway, right? I just hold it like this. And then have this hanging down. It might be a little awkward. Okay. The process on this wasn't that bad to set up Raspberry Pi. You do have to have a little bit of Linux experience. They have the documents are pretty laid out. Step do this, next step. So I had to install the operating system first, which is provided by the Raspberry Pi Foundation. It's just you install it onto the SD card. It boots up, and you just follow the on-screen steps. They have very detailed instructions. Then you obviously need to have an internet connection, whether it's via Wi-Fi or if you're plugging it into your your network at your house. And you install the DV software that will communicate with the dongle, which will allow you to run the encryption and decryption service. And then you build install these two applications. The dummy repeater is the software that I used in the X Windows that was allowing me to communicate. And then I plugged in this microphone because the Raspberry Pi doesn't have a microphone built in. So this would be cool at Starbucks too. You can plug it in and hear it. Hear me? Right out of Star Trek. Yeah, no good. So actually, it worked quite well. I connected to our local repeater, and nobody was listening, unfortunately, or it wasn't working. I don't know. But when I connected to reflectors around the world, I was able to hear people with my headphones because it does have the audio built in to the Raspberry Pi that I plugged into. I wasn't able to talk to anybody, so I still haven't spoken on the radio yet. I've been a ham now for 2 years now. I still haven't spoken on the radio. And then I tried to speak on here, it didn't work yet, but no one's answered me anyway. So maybe I haven't.
Development.
Yes, maybe it's my quiet voice, they just couldn't hear me. Now I was supposed to give you a demo. This is where I kind of fell short. I brought when I first got this, I set it up in Windows on my wife's laptop because I didn't want to mess up mine. And I got it working, but it doesn't want to work today. So then I decided after I confirmed this was working, I'd get my Raspberry Pi working with it, because the instructions for the Windows software was a little easier to follow because it's just install an executable and point clicks and set it up. So it worked quite well, and then I had this working earlier last night until I decided to make it a gateway and it broke it. So unfortunately I can't give you a demo of it tonight, but what I will promise, how many more sessions is there?
Of the How to Ham course?
Yeah.
This is the last session.
Oh great, so awesome. Knock that one out. Murphy's Law. I'll bring it with me to a club meeting if anyone shows up this Thursday.
This Thursday. This Thursday, Alan is going to be here.
Oh, that's right. Yeah.
So it's going to take the whole. So it's going to have to be September.
September.
Yes.
We'll forget about that.
Okay, so I'm going to represent in September. If you want to wait that.
4 months.
Or if anyone's interested in it, I'd be happy to set up a time and play with it because it is kind of cool. I'd like to release to get a module as well that has the relay. I want to play with that as well because I like to play with the radio and actually communicate with it that way. I should do that in the first.
Well, some of these dongles, I don't know the company, no one was there, but they have a sound card built right into the dongle.
Really?
Yeah.
Well, you sold me on this one.
Yeah, sorry about that.
It's all good.
And I have a question for you.
Yes.
You don't mind people touching it? I was worried that if there's a static discharge, you could blow some of it.
Yeah, you can.
Okay.
Don't rub your feet on the carpet.
That's all.
Keep
No.
your feet still.
Things now, they're not as sensitive as they used to be. I mean, you can still cause damage, and it's possible, but we don't worry as much about it anymore
okay.
as we used to. It's just not quite as sensitive. Yeah, I've run across my floor with this holding to my head. And it survived.
What do you program it? What do you use to?
The program. If I realized that I was going to break it, I would have got some screenshots before I broke it. But I can maybe I'll show you on the break maybe. I don't know how this is going to turn out on the. But this is the Windows software. I don't think this has a. What does have HDMI? What will happen if I plug HDMI into this? Is it going to blow things up?
You might not get it back up.
I might not get it back. Yeah. Basically, what it has is a very simple interface on here. You configure it to pick your device. You have to configure your call sign in. Your call sign, you have to be registered. If you don't register your call sign with the Dstar Network, You can still do point peer-to-peer, and you can do, depending on the local repeater, they may allow you to locally use your radio, but to communicate across the internet, you need to be registered. And usually we have somebody in the club that will register you. There's organizations on the web that you can fill out, but I asked Bruce to take care of it.
Yeah.
You put that information in, and then you need to know what repeater you want to connect to. And okay. Yeah, went to sleep. Okay, so I broke this too. Awesome.
September.
What are you doing? Can you change it for me? The next slide. There we go. So I was saying you need to be registered to the Dstar Network. You have to program in here which reflectors and which repeaters you want to connect to. And there's a couple resources that I found very handy. Was the dstarusers.org is a list of repeaters on the internet. Again, this is my experience. I don't know if it's the best place or not. But going on there, I was able to look up our local club, which is, I put a link here, but I don't expect you to write that down. I'd be happy to email it to anybody. You do a search for ours, which is VA3SNR, and it will give you the IP information. It gives you the network site, and you actually program it in here by selecting, there's a gateway button, and you put the address in. And if you connect to a local repeater, you'll be able to communicate with people locally, or you can connect to a repeater in Australia and broadcast in Australia. There's another site as well, DstarInfo.com. That's a list of reflectors. Now, this is where my noob experience is going to come in. The way I figured it out, and correct me if I'm wrong, a repeater is basically, it's an analog device that will repeat over a radio frequency, where a reflector has no connection to an actual radio. It's IP based, or it's computer based. So it'll only forward from one IP device to another IP device. So you can connect a repeater to a reflector, right?
Yes.
Okay, whew, I was right. So a reflector you can connect to, and you will be communicating with people that are specifically connected to this device based on their DV dongles, or if they've somehow wired their repeater into it. And is ours connected to any reflectors?
It is at times for various nets.
Like for nets?
Yeah, there's a controller that will at certain times put it on certain reflectors.
Do you know what times these are? I'd be interested in
Yeah,
that.
on Monday night at 8 o'clock, on
So-
Wednesday at...
Is that resource on our club website? Do they list that on our club website?
no.
Because for me as a newbie, that would be kind of cool. Because I'd like to know when our local device is connected to a reflector, so that I can listen in to people that are communicating to our net around the world. Or if
Yeah.
we're connected to that, that'd be interesting.
There's a Wednesday night net, and there's a Friday night net as well. Isn't there a
So-
Sunday night net too? Yeah, I think there's a Sunday night. Yeah.
On the Dstar Info page, they actually have a list of nets as well that have been published, and I've connected into those where it says Eastern Standard Time at 3 p.m. in the afternoon from this reflector there's a net going on. So I've connected to that, and I've listened in. I've listened to people talking and communicating from around the world, calling into the nets. It's pretty neat. When I was explaining it to somebody else, they asked me, well, why don't you just use Skype? Boo. That's
Not as much fun.
That's not as much fun. You don't get this. Well, I guess you can run Skype on my Pi. Oh, boo. Our local club is AARCclub.ca if you're not aware of it, but we also have some resources on there, some links to these sites as well on our webpage. So if you want to just remember ours, and you can connect to the rest from there. So in this application, there's some buttons at the top. You basically set your favorites. So you can program in this reflector, our local repeater. You click on it, you click connect, and you're in. It's that simple. Now what I'm going to do, because I didn't have a demo, maybe I will connect to one of these websites. Oh yeah, I broke this, that's right. Oh my god. That's what I get for buying cheap things. I always buy things when they're on sale. I got these for like $10
From China.
from China. Yeah. I just charged the battery too. That's good. You're back a page, and let's open up. I'm going to go to. Let's go to dstarusers.org. I should be able to. No, this one here. Should be able to client. So the interesting thing that I found cool, because there isn't I found a whole lot of traffic on the Dstar network. There isn't a lot, at times when a net's going on, there's a lot of activity. I don't know if you find the same thing or not, but a lot of times it's just quiet. So at first when I set up, I didn't think it was really working, because I don't pick it up anybody. But this site is cool, because it actually lists, on the home page here, it actually shows who's reported in, their call sign, and what actual node they were reporting from. So I've gone on here and I've refreshed and said, oh look, there's activity on this reporting node. So I've connected to that one on my DD node, and so I can listen to what's going on currently. So this is a quick little way to find traffic on there. And this utility also has the directory. If you click on it, you can search for, you can type in a country, you can type in a city, you can type in coordinates, whatever you're looking for. And you can find the repeaters around the world that are in those areas if you want to specifically communicate with someone in that area. So I found this one as a new person very handy. So if you're interested in Dstar, I would try that out for sure. Yeah, close that. And if you want to open up the other one, why not? I think I have last time because my demo failed. I'm just going to keep saying how badly I failed. So on the Dstar Info, we have repeater maps and lists, so you can actually bring up a global map, kind of like a Google map. You can zoom in on the world, you can find a location, and it'll show you all the repeaters and reflectors in that area, which works well here. Must be the North Pole, it's snowing. We have, there's just a list of reflectors. So around the world, where they are, their basic usage. Some will have certain etiquette and different guides that you'll want to follow before you connect to them. How many reflectors is there, do you know? There's quite a few anyway. But all of these, when you click on them, the status, you can get their address, and then you can program them into your, here. I think there's a way to, which I haven't done yet, to import them all into the DV node, so you don't have to look them up. But I didn't have as much time to spend with that because I was playing with that, which had them all in there before I broke it. If you want to go back a page, so this is where you can find the nets. So if you're interested in listening to any nets, it has a list of nets around the world. And it tells you their time and the description of them and which reflector they're on. So you can search around and find connections to go through. So that's Dstar. I apologize that couldn't let you hear anybody, but oopsie. The next part of my presentation is because we kind of started talking about the Raspberry Pi, and it brought into one of my passions, which is electronics and microcontrollers. So what is a microcontroller? Well, a microcontroller, as defined by Wikipedia, or MCU for short, is a small computer. A single integrated circuit containing, inside it has RAM, it has the processor, it has cache, it has I/O capabilities, and a lot of them have crystals in them, so they can actually have their own clock in them. So they're a self-contained computer is really what they are, a very miniature self-contained computer, where a normal PC is built up of many components, even the Raspberry Pi. You'll have multiple components. One's your video card, one's your sound card, one's your what have you. Where these devices here are the single chip computers. So they come in all kinds of different sizes. Change the next one. There's some popular ones that I work on a lot. The big granddaddy is the PIC microcontroller, which these are. It's from a company called Microchip, believe it or not, and they have been around for a long time. They're one of the first guys to come up with a really usable small form factor microcontroller. They come in 8, 16, 32-bit controllers. This one here, this one's 8. These are both 8-bit controllers, which I'll pass around in a minute. They come in multiple different types of packages. These ones are DIP packages, dual inline packages. These ones are also through holes, which I like to use when I'm using my proto boards. So they can just stick in here nice without having to do any soldering, so I can wire things up. They come with such an array of formats. There's literally thousands of them, of different. Have more RAM, they have more input output, they have different interfaces, more serial ports. Anything you want to do, you make a list of the types of ports you need. I'm sure Microchip will have them. We'll have a specific model, will have the number of components you need. Now, these guys will mainly program in assembly, or C are the two big languages for these guys. But you can get to other high-level languages, but they're not made by Microchip. They'll be third party. But the Microchip supports C and assembly language, which is the low-level language that everything is converted to. I'll pass these around. There's 4 here. These ones is a 28-pin, and this is a 40-pin I/O.
Sure.
And then Arduino, which has become more popular in recent years, just because they are easy to interface with and to prototype things with. I have a couple different Arduinos here. A couple of popular ones are the micro. Oh, I forgot my Mega. But the nice thing about the Arduino is this one is a dual inline package, just like those other ones that are going around. And it once I'm done with this board and I've configured a program on here, I can actually pull this chip off and put it into a circuit that I've designed, that I've tested with this, which is handy. Some of the models, they have their solder on, which you can't do that, but that's what I like about these ones, because I'll prototype when I'm working on with these, then I'll just program them on here, put them on something else. So these guys, they come in different flavors as well, 8, 16, 32-bit. And the one advantage that they have is they have, on the top here, they have these 2 rails of pins, which are shields. You can add a little shield to it. So to upgrade interface, probably should open these first. This is a shield. What this one is it's an SD card shield. So if I want to be able to add an SD card capability to whatever device I'm creating or coming up with, evil thing, they just clip on. I wouldn't say clip is the right word, but they connect on. And then they also have the headers on top, so you can stack these devices. So you can have multiple interfaces. So now I've added SD card. I've got a relay board, so I can control high power devices. So this one allows me to use the 3 or 5 volt, depending on the Arduino module, to control up to, I think these ones will, 250 volt devices that can turn on and off by connecting through here. This one's got some little extra plastic, maybe because it's high voltage. Zappy zappy. So you can continue to connect these, and as long as the devices that you're connecting don't use the same pins, the same GPIO pins, then you can keep stacking them. Or you're going to have to write some pretty funky software. So I've got relay boards, I have SD card boards, I've got ultrasonic sensors that just plug into here. Ethernet, if you want to put it on the internet, you can turn this into a web server. You can put the Ethernet shield on there. The other interesting one I have is GPRS. So a project I'm working on where from my remote airplanes, I'm putting them on the cellular network. So for me to communicate for telemetry for my airplanes, I'll use this. It's basically a cell phone on a chip. Will plug it in. I'll put my SIM card in there, and I'll be able to communicate text right from my airplane. It can text its status, text its GPS coordinates, and I'll be able to send commands to it across the cellular network via texting from my cell phone if I wanted, which is kind of cool. Started playing with that. So as long as you're in an area that has cell phone reception, you're good. I'll pass some of these things around. Much different.
Thanks.
And then from Arduino, there's, wow, look at that spelling, good. There's Parallax propellers, which is they're a little newer on the market, but they're different. They went with a different mindset. And the one I have here is another. It's a dual inline. Oh, sorry, I'm out of your frame. Dual inline package. This one is similar to a microchip where it's 40 pins, but the difference of this guy, it's 32-bit, but it has 8 cores on it. It has 8 processors. So with the 8 processors, it's not like an 8-processor computer at home. This one, the 8 computers basically run simultaneously by themselves. You can assign code to each processor individually. However, they can communicate between each other. So what you can do with these is, for example, on a microchip controller, they'll have a serial port, a specific pin on that chip that's meant just for serial communications to a computer or to a device that will communicate serially. This doesn't have those types of pins. They're all general purpose I/O, just to turn them on and off. And what they decided to do was to control serial or to control communications with the bit bashing format. What that is instead of actually having hardware that's monitoring a serial port for the ones and zeros, it's actually using software to emulate the hardware. So you would assign one of the processors to be a serial port, or you assign one of the processors to be a VGA port for your computer. It's actually capable to use 2 of the pins on here, and you can, 3 of the pins, and it'll send out a VGA signal. You can connect it right to your monitor right from here. It's crazy. So that was their idea. Instead of having multiple thousands like Microchip has of so many different flavors that have different interfaces, they thought they'd make one device that basically you can program to be whatever interfaces you want. So that was their way of doing it. It looks the same as that. I guess I don't really need to pass this around. The downside to the Microchip and the Parallax is you need a programming board. You need a programming device like one of these. You have to take the chip, you put it in here, the USB, you connect it to your computer, and then you have to basically burn the image onto your chips and then put them onto your proto board. Now there's in-circuit controllers as well, but the problem with programming them on the board is you have to assign certain pins to be the in-circuit update port, or you have to do some complex electronics so you can use those pins and use it to update the software. So it's just easier to use one of these. Okay. That's what I use.
To reprogram them?
Yes, you can reprogram them. Some of the chips 100,000, 200,000 times before they all burn out or they'll start. Look at their data sheets; they're all different. If you want to skip to the next one, kind of talked a bit about this, but what can you do with all these devices? You use them for interfacing with things. There's the general purpose I/O, which we call GPIO, which is just turning a pin on a microcontroller on or off, so 1 or a 0. So you do that it's like a switch, on off. So if you want to control an LED or you want to control a relay, you just turn that port on or off. That's general purpose. You can do serial communication, LV, which means low voltage, because these devices run at 5 volts or 3.3 volts. And most computers communicate at 12 volts, the serial ports on a computer, so you would need an interface to go between them if you want to communicate, or the 12 volts will fry your microcontroller. I2C, which is another serial communication protocol. SPI, serial peripheral interface, is another serial interface protocol. Now, the reason I have so many different serial communication formats is there's different devices that use them. Different manufacturers hung on to a specific standard for their devices for interfacing. So they tried to cram as many things into these chips as possible so you can communicate with as many things as possible. The USB HID, which is a human interface device, so you can write your software to emulate a keyboard, emulate a mouse, emulate joysticks, game controllers, those kinds of things. I'm building a main box right now. I'm not sure if you know what that is. It's a arcade machine emulator, and it's actually running on Raspberry Pi, and it has every single arcade game ever made. So what I'm doing is I'm building just like an actual arcade machine. I got all the buttons and the joysticks, and I'm using these, and it's connecting into my Raspberry Pi. So to the Pi, it's going to look like it's a keyboard, but it's going to have all my buttons and my joysticks. Because most of the old video games, they just saw up, down, left, right. There wasn't any real analog controls. So that's how I'm programming it to work with that. PWM with this pulse width modulation. That's how to explain that. The servo, you're another fly guy over here. Yeah, with servos, what it does is it has a rotation point from A to B. It's about 180 degrees, and depending how long you pulse the line high to 1 and off again in a certain amount of time. It measures, I forget how many nanoseconds it are. Like I'm just gonna make it up, so don't copy me. Let's say from 50 if it's on for 50 nanoseconds, it's gonna go at 90 degrees. And if it's pulsed high for 60, then it's just, the longer it's pulsed, the more it's going to move the servo. So you control it by turning the frequency of how long your pulse is on. Wow, that didn't sound very good, but hopefully you understand. DAC, a digital to analog converter. So that would be converting digital to analog. So that would be converting digital format sound out to your speaker to turn it into analog so we can hear it. ADC is the opposite, so that would be converting our sound into a digital format into the computer so it can retransmit it. That would be using a microphone, or it could be using, if you want to measure the voltage of something, you could do that as well. So it'll generate a number based off of the voltage you put into it. Digital signal processing, that's a little more advanced topic. CAN bus, that's a controller area network. That is what they use in cars, actually. Every part of the car has a sensor on it. They all communicate across this common bus, which is the CAN bus. You can actually write these things to plug into that and listen to what's going on in your car. You can use it to actually have some fun. I've played with it in my car, and I've been able to make my speedometer do things. Kind of fun. And you can do arbitrary waveform generation. I use that a lot in computers. When I'm testing things, I can use it to generate a certain frequency. If I want to, if I'm setting up one of these microcontrollers, I want to test something at 20 megahertz. I have a microcontroller that is a arbitrary waveform generator. I just have it do a pulse waveform at 20 megahertz, and I have a signal. I can have it do a sine wave. I can have it do sawtooth. You can program them for. I'm sure there's probably an application you can use it for in ham. I'll think about that. You might be able to use it for CW.
Yeah, for code. Yeah.
For code, yeah.
Yeah.
What frequency is it? A frequency that or is it just on or off when you're?
It's an on and off, usually 750 or 800 hertz.
So we could probably create that waveform right from that.
Yeah.
Cool project. So these things, depending on what flavor you go with of microcontroller, you can program them in different languages, different programming languages. Some are easier than others, depending on how in-depth you want to get. Arduinos, their go-to is the Sketch, and it's what we call a C-like. It has very straightforward, if this happens, then do this, or do this. So you can kind of read the code. It follows a certain structure, so you can follow through it. They have a lot of software examples and things you can include in your code, so you don't have to worry about it. If you want to control a servo, you just say include servo control in the top, and you can just say servo 1, go to this angle, basically. So they make it easy for you in the Sketch language. Spin is the one Propeller uses, but it's their version of like Sketch. Then there's C, which has been around for a long time in computers. The BASIC, just like the old Microsoft BASIC on my Commodore. You can program them in those. As long as not all of the microcontrollers will accept all these languages. You'll have to do some research. If there's one that you're familiar with, you might have to gravitate towards that microprocessor. But a lot of people are going towards Sketch and the Arduino just because of the availability of all these shields and relatively inexpensive. Speaking of cost, I'm like a squirrel. Speaking of cost, just to speak to that for a second, the Arduinos, they come in different flavors, as I said. They range generally, if you buy an actual genuine Arduino, probably about I guess $30 to $50. I'm gonna say you can get the knockoff ones because they're open source. You get the China versions for $5-6 bucks. The Raspberry Pis are $35. The advantage, okay, let's get that. See, squirrel. The Microchip controllers, depending on what you want, depending on how many ports you want, how much memory you want, and that kind of things. These ones, each one of these I think were 75 cents. You can get them anywhere from 75 cents up to a few dollars, $10, depending on what level. These are 8-bit. 8-bit's all I usually need for doing a lot of my simpler interface and things, so those are generally cheap. The more expensive, the 64-bit or 32-bit, you're gonna look at maybe $10 max for one. Like that would be a pretty powerful device to be $10 for one. As for the Parallax, those are $10 because they only come in one flavor, $10. So the cost of them isn't, is that true?
Just like the one in that silver pack.
Oh yeah, this is the Parallax, yeah. These are $10. These ones, they come in the dual inline package, so you can plug them in through hole, but they also come in the soldering format if you want to solder it to your board as well. Those are the only two flavors they have. And these will run up to 80 megahertz. The Raspberry Pi 3 is 1.2 gigahertz. The Arduinos can vary 8, 16, 20 megahertz. I don't think those are faster than that. We'll go with that. And for the what's the one I have left there? Oh, the microcontroller. The Microchip microcontrollers, they vary from 1 megahertz up to hundreds of megahertz. Some of the 64-bit ones can get into the gigahertz as well, but they're very custom. There's all kinds of other different languages you can program in. The reason I have asterisks on assembly is when I need to control how fast something is. Like for example, when I'm writing the code to control the servo, and you need something to happen within nanoseconds, I write an assembly language. Assembly language instruction, it takes the exact amount of time. It takes so many cycles for the CPU, so you can calculate by the commands you put into the assembly language program exactly how long it's going to take to do something. So you can precisely time servo mapping or precisely time network communications like serial ports, those types of things. Those are the only times I use assembly. Other than that, I like to use C because it's easier to read. Assembly, to do something assembly, let's say you want to, I don't know, read a keyboard in assembly language, it's going to take me hundreds of lines of code. In C, it's only going to take me 1 or 2 lines. Because you have to actually control every bit, and you have to move things from one part of memory to another, so you're in complete control of what it's doing. But there's only about 20 commands that they have, so you just have to know 20 commands, and then you have to make everything work based off of that. including math. You've got to figure it all your own. You have to do binary math, which is kind of fun. But that's the best way if you want something that has to be an exact speed. I was saying before, when I mentioned that the club meeting is for my model railroad, I set up my trains, they have a receiver in them, and I changed I swapped the plus and minus on the rail back and forth at a certain frequency so that I'm sending a digital packet across it like a network. So it has to be at a very specific speed or the train's not going to see it as a message. So all that's written in assembly language. So the beautiful thing with C and many of these other programs, you can write part of your program in assembly, and you can write the rest of it in C. You can call the assembly language part from the C program. So the communications part you can just write in assembly and then call it from a simpler C program. So you can do a lot of different mixtures that way. Do I have another page? Cool. Oh, cool. So how can a ham use this stuff? Well, I just did a quick search on the internet to see what kind of microcontroller things you can do for ham radio. Random code practice generator. A CW beacon and fox hunt keyer. A fan speed controller, so if you need to control the speed of a fan to keep your equipment cool, you can do that. You can set up a sensor, monitor your equipment. You can expand upon that. You can monitor the temperature of your equipment. You can log it. You can send it to your phone. You can see the statistics. You can create digital compass, weather stations, the RF probes. You can do solar battery charge monitors if you have an off-the-grid solution. An on-air indicator, simple project. A talking SWR meter. Interesting. Use digital to analog converter and do some speaking from it. You can have a talking GPS. Is it lambic? Is that iambic keyer? So that's what you use those, right?
Yeah.
So you can create an iambic keyer. Again, waveform generator. You can do, which I thought was kind of cool, is get a standard keyboard and have it actually create the CW code from that. So I'm just typing away on my keyboard and it's doing
Yeah.
so it's doing the code for me without actually going through a computer. It'll just go right through the microcontroller. Field day satellite tracker. You can do azimuth elevation rotator controller. You can have it monitor and control your antennas if you need to rotate them, and you can do all kinds of cool things. And that was the first list that came up when I just typed in ham radio microcontroller. There's a lot of things you can do with these things, and they're really not that hard. Like anything that you do, it seems overwhelming, but everything is just small pieces that you put together and you build into something bigger. So you start off with just turning on a light, turning it off. Then you turn on 2 lights on and off, and then you press a button and the light goes on and off. You just slowly start building up, and next thing you know, you're doing some pretty cool things just with a bunch of simple little things added together. So this kind of leads into a plug for something that we've been talking about is in January? Is that when we're looking at doing the course?
Yes, of course.
We're looking at doing a microcontroller course in January, if anybody's interested. Where it's going to be, what, a 9-week or 7-week course?
Yes, 7, I think. Yeah.
I get to dictate it?
So you get to tell us.
We're going to do a course on microcontrollers. It's going to start right from the beginning, programming, where each class is going to include equipment, and we're going to walk you through all the steps to actually make some simple devices. And by the end of the class, you should be able to write code and compile things to do almost anything you want just from those building blocks. So sometime in January, I'm sure Bruce will advertise that if anyone's interested. So thank you very much. I'll step over here. And if anyone wants to see this thing working once I kick it, let me know. You can reach me at nerd@mattcave.ca. Nerd. Matt Cave.
While you are parking that, can I ask a question?
Nope.
Yeah.
No, I'm not. Time's up.
Questions?
Not till September.
It's your turn now. So
I give you some time from my time.
Yep. Yep. Go ahead.
Actually, you still got 2 more minutes.
Oh,
Yeah.
Geez,
Oh,
you're
yeah,
talking
you do.
that USB microphone, is there a hidden A2D chip in it?
yes,
Or-
it is, yeah.
I was worrying, how do you talk to it and it gets
Yeah,
stereo code?
it looks like a sound card when you plug it in. It has a USB sound card
So
device.
it
Yeah.
has electronics in it.
Yeah, yeah. So when you plug it in, you'll be able to see it as a sound device when you pick your mic on your PC. So, yeah. Yeah, I know. I was worried it wasn't going to work with my Pi, but I found it in my junk drawer and it worked, so I lucked
Oh,
out.
that's a good thing to have.
Yeah, yeah. Use what you got. As my wife says, I have too much stuff. I don't think I have enough.
What was the other question?
I have a question
Yeah.
on the Dstar.
Yeah.
How? What's the difference between the Dstar and the Echolink?
Oh, Bruce.
Echolink is analog,
Redirect.
and Dstar is digital.
That's the main difference.
That's the main difference, yes.
And it works the same?
It works, yeah, it works basically, the procedure's a little bit different, the actual procedures, but it
So
works
the
basically.
Echolink won't require a dongle, I guess, to do the
Doesn't require a
encryption,
dongle.
decryption. So there's probably open source versions for Echolink.
Yeah. Echolink, you have to be registered. IRLP, you
No, you
just,
Echolink, you don't have to be registered.
no?
If you're only using a PC program or your phone, then you have to register with your license. But if it's on a repeater, you can just key in whatever you want on the IRLP.
Yeah, if you have a cheaper handheld, we have a repeater in town that works on the IRLP. You just key it in and you use the keypad, dun, 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 and for the node that you want. And on the course here, Mike was talking to Las Vegas. We tried to get Antarctica, but that didn't work. Nobody was there. We connected, but nobody was there. So it's pretty well straightforward. But Dstar is digital. And the advantage of digital, the sound is a lot better.
Yeah, I should mention that. Because it's digital, if you get the sound, it's going to be clear. Because it's converted digital at the point where it's spoken to the microphone. So the same quality that goes in is going to be the same quality you get out, as long as you get all the packets. So either you get nothing or decent quality is really the way it should work.
There are problems with Dstar. You know, if you had your radio, an analog radio, you took the antenna out and you put the antenna further, the PL259, you put it further, the signal will just fade. Right? It'll just get weaker and weaker and weaker until there's nothing. If you did that with Dstar, what will happen is it won't fade, but it'll hit a point where it breaks up. It'll, and then it's gone. So that, so it's different. And the other thing is, because there's so much switching time involved in it, you got to go through your repeater, and it's got to switch, and the other repeater, and et cetera, that you have to actually pause. You have to make sure you got big pauses in there before you transmit. Otherwise, you'll be transmitting, but the system hasn't caught up to you yet. So the problem with that on the net is, with analog, you usually hear the two signals, right? If somebody's on top of each other. With digital, the first one.